Hello everyone, myself Krishna Raj, Assistant Professor from the Department of Automobile Engineering, Hindustan College of Engineering and Technology, Coimbatore. In this video lecture, we are going to be elaborately discuss about the combustion theory for automobile IC engine, internal combustion engines. Combustion phenomena in CI engine, compression ignition engine or diesel engine. So we know well known about that the working principle of diesel engine. So it is having four strokes called to be as in suction, compression, power and exhaust stroke, and it is having five processes. So suction is an induction of charge, and compression is an compressing of gases, and the next is combustion is an another process, then expansion and exhaust is an another process. Namely, four strokes, five process should be carried out for completing the one cycle of the crankshaft in diesel engine. So during the suction stroke, the air is being admitted into the cylinder, and during compression stroke the air only compresses in this compression stroke. At the end of this compression stroke, so diesel fuel is injected at the high pressure. So at the end of compression stroke, what happened means, so both the valves are getting closed and air is compressed, so the volume is getting decreases as well as the temperature also getting increases. So by this time, so it has a compression ratio in the diesel engine nearly about 12 to 22% in this of compression. So at high temperature and pressure, the fuel is injected as a fine particle. So what happens? So it will take an fine atomization as well as vaporization occurs, and it will reaches the self ignition temperature. Then only the combustion process will start. So namely, it is having an combustion is an only one single process, but it has a difference in the stages. So that will be discussed in the next. The combustion in CI engine taken place for four stages. So the first one is ignition delay, first stage. Then second stage is rapid or uncontrolled combustion. Then third one is controlled combustion. Fourth one is after burning combustion. Right? So it is a stages of combustion. So on which you can look into this at the bottom side. It is crank angle, right, from the 0 degree to 180 degree, and the vertical line that shows the pressure in terms of kg per centimeter square. So that is pressure in terms of rising right from the BDC. So bottom is in BDC to TDC. Okay, so the first one is ignition delay. Yes. So the first stage called to be as an ignition delay period in the combustion phenomena. So right from the at the end of compression stroke, so the fuel is injected. So the ignition delay period will starts from that start of injection to the start of combustion. You can look into this graph. So the start of injection, so it is the period the fuel is start to inject inside the cylinder, and the start of combustion is the next stage. Okay, so the start of injection to the start of combustion, in between this period is called as an, what is that? It is an ignition delay period. So it is a mixing period, called to be as a mixing period, right? So the fuel is injected into the cylinder. By this time, inside the cylinder high pressure and temperature will be maintained. So fine atomization and vaporization will start, and it starts to burn. That is a combustion which will take place. So if the combustion is not taken place, means that will follow this motoring curve. It is called as an motoring curve. So motoring curve is nothing but it is a failed of process. So the engine is not getting started. Even though the fuel is injected into the cylinder, the combustion is not initiated. So it will be sent as a smoke or exhaust gas emission through the exhaust tailpipe. The engine is never get started when it follows the motoring curve. So this ignition delay will have an two distinct parts called to be as an the first stage is called as an delay period, so on which it is having in two distinct parts, that is in physical and chemical delay. So on which physical delay, so when the fuel is injected into the cylinder and it starts to atomize and vaporization, and if not, so the combustion is not taken place due to the physical properties, then it is called as an physical delay period, which means that it is not properly mixed together by means of some physical characteristics. It is not well atomized and it is not vaporized inside the cylinder. It is due to which the type of fuel, the first thing is an type of the fuel, what kind of fuel which we are used, and then injection pressure. For example, the petrol engines or diesel engine, the respective injection pressure is not maintained, means so the atomization and vaporization is not occurred. So the fuel is, for example, in diesel engines, so around 200 to 300 bar pressure is maintained for the injection pressure. So if less than that, means so the vaporization is not taken place, and due to which the atomization also not properly happened. So the auto ignition, self ignition temperature is not reached for that. So it is one of the physical delay. Then second one is a type of the nozzle for used in the injectors. So normally we have an pintle, pintax, single hole, multi-hole nozzles are used, and like in split injections also we are used for maintaining the proper combustion and reducing the physical delay period. So the type of nozzles plays a vital part in this delay period. So the type of nozzles like in pintle or pintax, suppose sometimes the nozzle holes are getting blocked due to that, so dropping of the fuel also will make a physical delay. The next is a temperature. So the engine temperature at coolest part, so the engine temperature is very low, means so it takes time to vaporization. So the engine temperature due to which atmosphere condition and like an engine coolant, oil, lubrication systems, which reduces the temperature of the engine while starting the engine, right? So at this time, so it's try hard to struggle to start the engine. That period is called to be as an physical delay period. The engine temperature as well as the atmosphere air temperature, so which influences the physical delay period, extends the turbulence inside the cylinder. So inside the cylinder in diesel engines normally it is followed by the turbulence, so which makes a proper mixing of air and fuel, especially for a diesel fuel. So it is a heterogeneous mixture, so it needs an internal turbulence factor. So then only it makes an temporary homogeneous mixture. The next one is a chemical delay period. That chemical delay period is purely based on the chemical properties of the fuel. So the chemical properties called to be as an quality of fuel and like in knocking index and others. For example, so for petrol or diesel, petrol, high octane petrols, which improves the combustion quality, and for diesel high cetane number fuels are used. Normally high speed petrol, high speed diesels are used. So what it makes, high speed petrol, high octane values are used, and high speed diesel, high cetane values are there. So which improves the combustion rate. So these are all the important things. So these high octane, high cetane fuels that reduces the chemical delay period and that improves the combustion rate. Ultimately that reduces the emissions in this part. Then the second stage is rapid or uncontrolled combustion. On this period, so marked over here, at the end of the first stage, that is when it is not followed the motoring curve, it starts to combustion. When the fire is initiated, then this particular period is called as a second stage rapid or uncontrolled combustion. By this time, so the rapid explosion is taken place. The high pressure, a high temperature air fuel mixture starts to explode. So the ignition taken place, the self ignition taken place, so it starts to spread out the entire volume of the cylinder. Huge explosion is taken place. That period is called as a rapid or uncontrolled combustion. We cannot able to control the combustion rate, and it is a rapid in time, the combustion which taken place. By this time it will reaches the maximum of pressure. It marked rises in the higher pressure, so it will reaches the TDC. So this particular point. Then next one is a third stage. This third stage is a controlled combustion. At the end of the second stage and to the at the start of fourth stage, in between these period is called as an controlled combustion. At this time the piston will starts moving from the top dead center to the bottom dead center. So what happens, ultimately the pressure drop will be there and volume is getting increases. So the controlled combustion rate will over there. By this time period the unburned hydrocarbon starts to burn with steady state. So it is a third stage. Next one is an fourth stage, is called to be as an after burning stage. So this after burning stage is at the end of this controlled combustion to the end of this cycle. This period is called as an after burning period. So after burning period is especially for burning the unburned hydrocarbon. So after combustion the unburned hydrocarbon is placed inside the cylinder, because the rapid time is given for completing one cycle. So we are not provided enough time period for the completing the entire combustion process. So at the exhaust stroke, by this time what happens, the unburned hydrocarbons will burn slowly. This period is called as an after burning process. The next is factors that influences or that affecting the combustion rate. So what are the external factors that affecting the combustion rate? Now the first one is an air fuel ratio, fuel type of fuel used, and initial temperature and pressure, electrode gap for petrol engines, turbulence, combustion ratio, load on the engine, and engine speed. So let me discuss it in deeply. So the first one is an air fuel ratio. So the air fuel ratio plays a vital part in petrol engines, especially for a petrol engine. So we are in the position supposed to maintain the stoichiometric range. So if you are suppose lean mixture means more quantity of air, less quantity of fuel, so which makes higher air percentage than the fuel. So what happens? So a high amount of oxygen and hydrogen present inside the cylinder, that will reach us before self-ignition temperature. So that makes a detonation in our engine, that ultimately affecting the combustion rate. So it reaches self-ignition temperature before that makes a detonation. And rich mixture, so rich mixture means higher amount of fuel is admitted into the cylinder, so that too also makes a self-ignition temperature in earlier. Okay, so that is an important thing. The next is a type of fuel we are using. So the chemical composition that present inside the fuel. So if a poor quality fuel, that never makes a proper combustion, because it is a quality of fuel is very poor, that never makes a self-ignition temperature, especially for a diesel engine. Only when the fuel is reaching the self-ignition temperature, then the combustion will start. Otherwise that never starts the combustion, that will follows the motoring curve. And if you are supposed to increase the combustion rate, means you have to use the high cetane fuel, so that ultimately increase the combustion rate in diesel engine. And for petrol engines, high octane fuels are used. And initial temperature and pressure, for example, atmosphere air temperature is very lower, means so the combustion rate will follows drop, because the air temperature is falling down, so that ultimately reduces the combustion temperature, and that will for a period of start of engine, the engine temperature also, when the engine is started newly, so what happens, so the engine temperature also very minimum. So due to the engine temperature as well as intake air temperature, so the engine is try hard to start the engine, the combustion is initiated after 1 or 2 cycles only. and pressure. If the combustion pressure, so blow by gases are more means, so this will increases that will ultimately decreases the pressure, combustion pressure. So only which reaches the higher pressure rate, then self ignition temperature will reach. Otherwise, due to the pressure drop by means of blow by gases, that will reduces the combustion rate. Then next thing is electrode gap. So that is applicable only for petrol engines. So in petrol engines, the spark plug will produce the spark to make an combustion. So by this time, if the engine is continuously running, so this electrode will starts to erode. Okay, so due to this erosion of this electrode, the gap maintained in between these electrodes, positive and negative electrodes, so due to this continuous process, the erosion will take in place, so in between the gap will increase. So it tends to make try hard to jumping the electrons from the positive to negative plate. So if the gap is maintained too high means, so the electron never jumps from the positive to negative. It needs more power to jumping of electrons. So normally we are maintaining the gap is 0.25 mm. If it is exceed more than that, what happens means, so the electron jumping factor will affect. So it needs more power to jumping of electrons. So this will ultimately affecting the combustion rate. The next is in turbulence. This will be applicable for the diesel engines. So of course diesel is a heterogeneous mixture, so on which temporarily we are maintaining as an homogeneous mixture by means of this turbulence. Inside that cylinder we are making an artificial turbulence inside this. This will makes to mix the air and diesel fuel as a temporarily homogeneous in condition. So within the stipulated time the combustion will start, so the proper combustion will take in place. If poor turbulence which will makes an improper mixing of air fuel mixture, ultimately that will reduces the combustion rate. The next is a compression ratio. For petrol engines that will have a compression ratio as from the 10 to 13:1, and for diesel engines normally 14 to 20:1. Right. So if the compression ratio is getting reduces, for example due to the wear out of internal parts, the compression ratio will starts to reduce. If the compression ratio is getting reduces, especially for diesel engines, so if the combustion ratio reduces means that reduces the pressure as well as the temperature. So ultimately auto ignition temperature also getting reduces, so that will never combustion will starts, that will follows the motoring curve. Then the next one is a load. If the engine load will increases, that will affects the combustion. So when the vehicle load is directly affects the engine load. So what happens due to this engine load, the engine is try hard to complete the cycle. So more amount of rich fuel is admitted into this cylinder. So either that will follows the motoring curve or incomplete combustion will take in place due to this engine load. The next one is an engine speed. During high speed, at higher engine speed, so we are not providing enough time to complete the entire process called to be as suction, compression, combustion and exhaust process, right? So normally in this combustion process it will have in 4 stages. So ignition delay period, the next is in rapid combustion, controlled combustion, as well as for the after burning process. So all those things we are giving only a rapid time within a stipulated time. So during higher engine speed conditions, so this will not make it as possible. So that will affect the combustion rate. Hope this video will enlightening you on this combustion theory and stages of combustion. So thank you all.